Fibonacci series with integral calculus. Fibonacci series with integral calculus. This is what the discussion we are pursuing. And now we are in multi-variable case. Fibonacci series through integral calculus. What is Fibonacci series? World knows what is Fibonacci series. What world knows is that Fibonacci series is a series of numbers, and in that series it begins with 1 and it proceeds 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. This is well said, as this is also we can call it an amoeba model, where there is an amoeba that is born today. If amoeba is born today, it will take 3 days, 2 days time to start multiplying into 2. Amoeba can multiply into 2 on its own. Okay, so if amoeba is born today, today is day number 1, tomorrow is day number 2, day after 3 onwards, amoeba is going to divide into 2 every day, once in a day. Once in a day, this is our model. So an amoeba is 1 today, child amoeba, tomorrow it is 1 again, and day after tomorrow, day number 3, it will divide into 2, mother amoeba, child amoeba. Day number 4, it will again divide into 2, so number of amoeba is 3. Day number 5, amoeba will get divided into 2 again, and number of amoeba is 4. But the amoeba that was born on day number 3, day number 5, it is ready to divide into 2. So number of amoeba on day number 5 is 5. Okay, what is the count of amoeba on day number 5? The amoeba which are available on day number 4, they will continue on day number 5 also, because amoeba are not dying. And amoeba that are available on day number 3, all amoeba will be ready to double itself on day number 5. So day number 5 number of amoeba is number of amoeba on day number 4, and number of amoeba on day number 3. Day number 4 amoeba, they are available on day number 5 also. And day number 3 amoeba, they are ready to become double. So function over x, if I have a series where x is 1, 2, 3, 4, that is a position number in the series. Every series has a position number. Position number 1, 2, 3, 4, and at each position, what is the value? That value we call it Fibonacci series value. So each position number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and value is 1, 1, 2, 3, 5, 8, 13, 21, and so on. Okay, so we can call it position number as day number, and Fibonacci value is amoeba number. So on day number x, I call it function bracket x bracket close, function over x. Function over x is amoeba count on day number x. Function over x is the Fibonacci value at position number x. Anything is understandable. This typically falls in a kind of summation series. In series, there are two terms, one is x and one is function over x. I believe it is understandable. Okay, so one is x and one is function over x. Okay, so this is x-axis and this is number of days. Day number 1, day number 2, day number 3, day number 4. What is the day number? Against each day number, this is y-axis or function over x. And at each day, what is the amoeba count, or I call it position number in a series? Then position number 1, 2, 3, 4, against each position number, what is the value at that position? That is Fibonacci value or amoeba count on that day. Okay, so what the formula is? Function over x. Function over x or amoeba count on day number x, or the Fibonacci value at position number x along the x-axis. X equal to 1, 2, 3, 4 is position number in a series, and at each value, each position we have a value. In very plain term, someone in writing on a notebook a series, and series is 1, 1, 2, 3, 5, 8, 13, 21, 21, 34, 55, 89, and so on. Against this series, what someone is writing in the notebook, that there are two things that is varying. No, there is only one thing that is varying. One, one, two, three, this is varying. Can you see it? This is called Fibonacci value. Fibonacci value is varying. 1, then it is 1, then it is 2, then it is 3, it is 5. There are two things that is varying. People are not understanding it. One is the what people are saying that is varying is called value. That is dependent component. And what is also varying behind the scene is the position number. Position number 1, position number 2, position number 3, position number 4, position number 5. These position number are represented as x, and what Fibonacci value we are seeing against each position is called function over x or Fibonacci value. What is the Fibonacci value at position number 5? That is 5. What is Fibonacci value at position number 7? That is, I believe, 13. Position number 6, 8. So fx and x is the index or day number, and fx is the Fibonacci value or number of amoeba. Fx equal to fx minus 1 plus fx minus 2 for Fibonacci number, or fx equal to a to the power x minus b to the power x by square root of 5, or I would rather say a to the power x minus in bracket minus b to the power x by square root of 5, where a is the square root of 5 plus 1 by 2 and b is the square root of 5 minus 1 by 2. A to the power x minus in bracket minus b to the power x divided by square root of 5. Okay, this is called Fibonacci value at index number x. This is the formula. Now, concept we are following, can there be two variable Fibonacci series? Right now, we have only one variable Fibonacci series, that is x-axis. Along the x-axis, I have a Fibonacci series, and that is the one value Fibonacci series, one independent variable Fibonacci series. On day number x, tell me the amoeba count. Day number x, the amoeba count is amoeba count on day number x minus 1 plus amoeba count on day number x minus 2. Can you tell me in relationship of x? Yeah, amoeba count on day number x is a to the power x plus minus or a to the power x minus in bracket minus b to the power x by square root of 5. What is a square root of 5 plus 1 by 2, and what is b square root of 5 minus 1 by 2? These are the two things. These are the amoeba count on day number x. Okay, if x is odd, minus b to the power x. If x is odd, then minus b will result in minus only, and minus is waiting outside plus. So amoeba count on day number x, if x is odd number, then it is a to the power x plus b to the power x by square root of 5. If x is even number, a to the power x minus b to the power x by square root of 5. This is amoeba count on day number x, Fibonacci number value at position number x. Can there be, okay, what is independent variable here? X is independent variable here. Fx is independent variable here. Many places people represent fx, f in bracket x bracket close, as u bottom right x, ux. People also represent fx as ux, u and subscript s, u and bottom right x, or f in bracket x bracket close, fx. Okay, this is how the Fibonacci number is also represented. Can you tell me ux Fibonacci number? u1, u2, u3, u4, u5. This is a Fibonacci series. u6, the Fibonacci value at position number 6. Okay, can we imagine a Fibonacci number where independent variable are 2? Not only x, independent variable is y also. This is x-axis, that is the day number, and this is y-axis, that is also a day number. There are two independent variable Fibonacci series. Okay, I understand. If it was one variable, then you said this is function over x. So vertical is the Fibonacci number. Understand? If it is two variable, this is x-axis and this is y-axis, where your value is, this makes xy plane. And on top of this xy plane, if I think about a z-axis, then that is the two independent variable Fibonacci series. Okay, what is your formula of Fibonacci series? For one independent variable Fibonacci series, fx equal to a to the power x plus, sorry, minus, in bracket, minus b to the power x by a square root of 5, where b is a square root of 5 minus 1 by 2, a is the square root of 5 plus 1 by 2. Okay, this is your Fibonacci series for one variable. Yeah, one variable. What about two variables? That I can think. There is no defined one. Let's take a Fibonacci series for dual independent variable x and y, and the vertical z-axis. If this is xy plane, then this is z-axis. Then z-axis again the Fibonacci function is fxy. F in bracket x comma y bracket close, fxy. What is your formula of fxy? Understood formula of fx is a to the power x minus, in bracket, minus b to the power x by square root of 5. What is formula of fxy? That we can deduce. It is not that natural the way Fibonacci is. Consider fxy equal to ux into uy. fxy equal to uy into ux. What is uy? Uy is the Fibonacci value at position number y in single dimension. One independent variable Fibonacci. What is ux? Fibonacci value at position number x in the single variable Fibonacci series. Or amoeba count on day number x, amoeba count on day number y. Consider fxy equal to uy plus into ux. uy into ux. Consider in that fashion. Now what you want? I want summation of this series. What is the summation of this series? Consider I have a series called summation x equal to 1 to m, summation y equal to 1 to n fxy, where fxy is uy into ux, uy into ux. What is that? That is fxy. Okay, if that is fxy, can you tell me this summation? Summation x equal to 1 to m, summation y equal to 1 to n fxy. What this summation will be? Okay, this summation will be, I don't know, but this is fxy is a discrete function. X, it is dependent upon x comma y, but x comma y always be a whole number. X is a number of day on which we are making amoeba, counting amoeba. Day number cannot be a fractional number. So fxy is a discrete function where uy into ux exists only for x and y as a whole number. What is uy? A to the power y minus b to the power y by square root of 5 into a to the power x minus b to the power x by square root of 5. This is fxy. Summation x equal to 1 to m, summation y equal to 1 to n fxy. This is what we want. Fxy. This is a series up to fm comma n. M into n. M into n variable. We want m into n, for m into n number of days, m into n. We want the total summation of this series. Summation x equal to 1 to m, summation y equal to 1 to n fxy. This summation series we want. What it will be? Okay, now as usual we describe it. So what we have now? This is xy plane, and this is x-axis going from 1 to m or 0 to m. This is y-axis going from 0 to n. This is xy plane. What is fxy? Fxy is the vertical at various x comma y. This is fxy. What is your fxy when x is 2 and y is 4? Then it fxy equal to uy into u4. Uy into ux. U4 into u2. When x is 2 and y is 4. This is what we want. X is 2, y is 4. This is the point. This is 2, this is origin, this is 2, and this is 4. At this point, what is your fxy? Uy, u4 into u2. U4 is 3, u2 is 1. That is 4 into 1, 3 into 1 is 3. What is your fxy at u6 comma at 5 comma 6, x is 5 and y is 6. U6 into U5. What is U6? U6 is 8, U5 is 5. That will be 40. Oh, thank you very much. What will be your two independent variable Fibonacci series value at m comma n? X is m and y is n. Un into un into a to the power n plus, sorry, minus in bracket minus b to the power n by a square root of 5 into a to the power x minus in bracket minus b to the power x by a square root of 5. Understandable? Okay, now someone will say, boss, depends upon. Now, if I break minus b to the power m minus b to the power n, what it will be? B I know. Depends upon the polarity of m and n. If m is odd number, then it will come out as negative. Negative is waiting outside a to the power n plus b to the power n by a square root of 5 into a to the power m plus b to the power m by a square root of 5, taking m and n both as odd number. We will do that one. Consider m and n as both as odd number. If that is the case, then what is summation of fxy? Okay, now to calculate the summation of fxy for m term in x and n term in y, where m and n are odd number, then what will be summation of this fxy? Okay, to calculate the summation of fxy, now fxy is a discrete function. Fxy is a discrete function and it is vertical at xy plane. Can we use integral calculus? To use integral calculus, I need to have a continuous function. Consider this is a continuous function. This is a surface. Consider this is a surface. Okay, this is a surface. This is a continuous function. This is a surface and it is a continuous function. Okay, now if this is a continuous function and this is xy plane, then what is the speciality of a continuous function? What is the speciality of a discrete function? If this is a discrete function, if I say what is your function at x equal to 0.5 and y equal to 1.6, then it is not defined. It is defined only at x and y as whole number. Continuous function is defined at any x comma y. X is 0.5, y is 1.99. Continuous function will be defined. Good thing about continuous function is we can do integral calculus over continuous function. If continuous function equation is gxy, if this is xy plane, and continuous function equation is gxy, if continuous function equation is gxy, if I calculate gxy dx dy, then it will give volume underneath it. If this is dropped like this, whatever air it is consuming, that is the volume. Not, I believe I'll take surface, that is better. Okay, consider this is a hollow surface and this is how the surface is. If this goes down, then whatever the, okay, consider this surface, the inside one. This is the surface. If this full inside one is the surface. If I take, if this is gxy dx dy from x lower x is x1 to x2, y is y1 to y2, what it will calculate? It will calculate the volume. If this is x1, this is x2, and this is y1 and this is y2, this will form a rectangular region here. X1 and x2 and y1 and y2, it will form a rectangular region here. This is x1, this is x2, this is y1 and this is y2. It forms a rectangular region here. If I take this rectangular region up, and so that it is going to hit this surface, whatever the volume I imagine and going to overlap with the round surface, whatever top, it will make a volume like this, and then it will go flat and hit the xy plane. Whatever volume that what I imagine is gxy dx dy from x equal to x, x equal to x1 to x2, y equal to y1 to y2. Anyway, if I talk about fxy, which is a discrete function, fxy is a discrete function. If I take any arbitrary point x comma y, if I take any arbitrary point x comma y, then fxy is available at x comma y when x and y are whole number. What is the next position where fxy is available? X plus 1 comma y, x comma y, then x plus 1 comma y, x comma y plus 1. At these 3 points, fx is available, where gx is available everywhere. That is a continuous function. Now, our concept is, can we find a gx from x to x plus 1, y to y plus 1? If I compute the volume with gx, that volume should be exactly same as log left bottom corner x comma y fxy. If it is same like that, then for each fxy, I have a gxy dx dy. If I say at any arbitrary x comma y, this is fxy and it has some value, like we calculated 2 fxy at 1 comma 1, 2 comma 4, 5 comma 6 or something like that. So at any x comma y, I have a fxy. For this fxy, I have, now if I take right side and if I take top side, then there is a volume that is generated from x to x plus 1, y to y plus 1, and that volume with gxy, if both are same, then we are knowingly, unknowingly, we are transforming our discrete function into continuous function. Now we will have a gxy that will represent exactly as discrete function fxy. Okay, if that is the case, if I am able to find out gxy, then for each fxy, I have corresponding gxy dx dy volume. If I add all the volumes, which are all the volume that is equivalent to adding all the fxy. This is what we want. But good thing about adding all the volume when they are contiguous to each other and non-overlapping, I can make a thorough volume calculation from lowest limit to highest limit. If I say I have a integration from limit is 1 to 2, 2 to 3, 3 to 4, 4 to 5, it is as good as integration 1 to 5. In between, I can take it out, not required. Okay, this is the functionality of integration. So if I integrate gxy from 1 to 1, x is 1 to 2, y is 1 to 2, then x is 1 to 2, y is 2 to 3, then x is 1 to 2, y is 3 to 4. Okay, up to x is 1 to 2, y is n to n plus 1. We'll try another row. X is 2 to 3, y is 1 to 2, x is 2 to 3, y is 2 to 3, up to x is 2 to 3, y is n to n plus 1. Last row. X is m to m plus 1, y is 1 to 2, x is m to m plus 1, y is 2 to 3, x is m to m plus 1, y is 3 to 4, and last one, x is m to m plus 1, y is n to n plus 1. The last region where we are trying to calculate the volume, it will go m to m plus 1, n to n plus 1. Then full summation, each integration is equivalent to fxy, 1 fxy. 1 to 1, 1 to 2, 1 to 2 is equivalent to fxy at x equal to 1, y equal to 1. Summation of all these sub-volume in integration is same as fxy, 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 fxy. If I sum it, it will go as x equal to 1 to n plus 1. So x equal to 1 to m plus 1, y equal to 1 to n plus 1. Makes sense? fxy dx dy. We have to find gxy dx dy. We have to find gxy. If I find gxy, then with doing the final integration, we are calculating knowingly, unknowingly, the summation of two variable Fibonacci series, that is uy into ux, or that is fxy. So to find gxy, we will start with fxy equal to gxy dx dy, x equal to 1 to x, sorry, x equal to x plus 1, y equal to y to y plus 1, x equal to x equal to x plus 1, y equal to y to y plus 1, dxy dx dy means if I take any point here x comma y, x to x plus 1, y to y plus 1, we get a area dxy dx dy, and that volume will be same as left hand side fxy. If I'm able to equate it and getting the gxy, then that will be a generic one. Fxy is uy into ux. Uy is a to the power. We have taken m and n as odd number. So m and n at odd number. That will come in the last stage. Now, right now we are calculating for any x and y. X and y itself can be odd number and even number. X and y can itself be odd number and even number. Consider y is odd, x is odd. Y is odd, x is odd. Again, so there are many combinations we can see here. Consider x is odd, y is odd. Then we have uy into ux, that is a to the power y plus b to the power y by square root of 5 into a to the power x plus b to the power x by square root of 5. If I keep x as fixed right now, keeping x as odd one, then we will try y for even also. Then we will try x for even, then we will try for y as odd and even. Okay, so four combination we have to try. We will try only one combination and let the people do achieve it for all four combinations. Understandable? Uy into ux, where x is odd number, y is odd number. Then we will try x is odd number, y is even number. Then we will try x is even number, y is odd number. X is odd number, y is odd number. Four combination we will try, where at the end addition will go up to m and n, both are odd. Then again we will switch one and then again try four combination. Then we will switch one, again we will try for means there will be 16 combination for gxy will come. We will try to get gxy for one combination where x is odd, y is odd. A to the power y plus b to the power y by square root of 5 into a to the power x plus b to the power x by square root of 5. The square root of 5, a square root of 5 is 5, that we will leave right now. What will be this multiplication? A to the power y, a to the power y into a to the power x, a to the power x plus y plus b to the power x plus y plus a to the power y, a to the power y, b to the a to the power y, b to the power y, a to the power 2y, a to the sorry, a to the power y, b to a to the power y plus b to the power y, a to the power x plus b to the power x, a to the power x plus y, b to the power x plus y, a and b, a to the power y into b to the power x plus b to the power y into a to the power x. Understand? Okay, a to the power y plus b to the power x, that is a into b to the power xy. B to the power y, a to the power x is a into b to the power x into y. Up, yeah, up. Okay, I think so. No, okay, a to the power, a to the power, up, a to the, okay, a to the power x, b to the power y plus a to the power x plus b to the power y plus a to the power y into b to the power x. There is no common factor we can take. Here a to the power x is there and there b to the power x is there. Okay, we cannot take anything common. What will be a to the power x into b to the power y? Okay, what is 2 to the power 2 into 3 to the power 3? Okay, we don't know. Is I think so. I think so. 2 to the power 2 plus 3 to the power 3. How much it will be? It will be 27. And 2 to the power 2 is 4. 27 or 2 to the power 2 plus 3 to the power 1. Okay, it will become 4 into 3, 12. Okay, can we take 3 into 2 to the power Hope. No, we cannot take. So they are not looks like they are not related to each other. So this is how it will be. A to the power x plus a to the power x plus y plus b to the power x plus y plus a to the power x b to the power y plus b to the power a to the power y b to the power x. Okay, this is how it will be. This is called fxy. For this fxy, I have to find gxy. For which gxy dx dy, limit x to x plus 1, limit y to y plus 1, the volume will be exactly same. This is what the concept we are following. Fxy at x and y, that is uy into ux, that is uy into ux, and that will be same as gxy, limit x to x plus 1, y to y plus 1. With that we have to find gxy. Okay, now we will proceed now. Fxy equal to gxy dx dy, gxy equal to d2 fxy by dx dy, means I have to differentiate fxy with dx and dy to get the gxy with a simple formula. Fxy is a to the power x plus y plus b to the power x plus y plus a to the power x, a to the power x, b to the power x plus a to the power x, b to the power x. Understandable? A to the power x plus y, a to the power x into b to the power x. Okay. Anyway, this is how it is. Equal to, now if I differentiate with x, then it will become log a to the power x plus y plus log b to the power x plus y. If I differentiate with x again, then it will be log a to the power x, b to the power y. Okay, next is log b to the power x, a to the power y. Now we will differentiate with y again. We will differentiate with y. Hope we will differentiate with the y. Okay, first I differentiated with x. A to the power x plus y, if I differentiate with x, it will become log a to the power x plus y. Similarly, things will change. If I differentiate with y, then it will become again log a. Log a into log a to the power x plus y plus log b into log b to the power x plus y plus we had a to the power x, b to the power y. First it become log a to the power x, b to the power y. Now it will become log b, a to the power x, b to the power y plus log a, log b, a to the power y, b to the power x. This is what the differentiation, and we will start gxy with this expression, and that is log a into log a to the power x plus y plus log b, b to the power x plus y plus log a, log b, a to the power x, b to the power y, log a, log b, a to the power y, b to the power x. If I keep this and integrate it with dy first, then one log a, log b, log b will go away, and whatever will remain, that we will place y to y plus 1. What is log a and then a to the power x plus y? Limit is y to y plus 1. Okay, then a to the power, we have a to the power x plus y, a to the power x plus y plus 1 minus a to the power x plus y. Okay, understandable. We can take out a to the power x plus y. Remaining will be a minus 1. A minus 1. Similarly, here remaining will be b minus 1. Understandable. Okay, and then same thing we will apply there also. Now we will integrate with the dx, a to the power x plus 1, x plus y. If I integrate with dx, then it will be whatever it is by log a. If I integrate with dy by log a, log a dual time differentiation, they will vanish. First time integration with dy, it resulted in a to the power x plus y in bracket a minus 1. If I integrate with dx, then again it will represent it, a minus 1 term will come again. a minus 1 a to the power x plus y. If I integrate with x and then set the limit x to x plus 1 a to the power x plus y plus 1 minus a to the power x plus y a to the power x plus y, and then a minus 1. So net integration will come as a to the power x plus y in bracket a minus 1 whole square plus b to the power x plus y b minus 1 whole square. Similarly, it will be settled down for a to the power x b to the power y a to the power y b to the power x, where a to the power x b to the power y log a and log b will go away in dual integration. First integration with dy a to the power x b to the power y, it result will be a to the power x b to the power y plus 1 b to the power y plus 1 minus a to the power x b to the power y. If I take b to the power y as common factor, then it will be b minus 1. Similarly, it will be b minus 1. If I integrate with x and take limit x to x plus 1, then it will be a minus 1. Okay, so it will result as a to the power x b to the power y a minus 1 b minus 1 a to the power y b to the power x a to the power y b to the power x, again a minus 1 b minus 1. Understandable? So these are the extra thing we are getting. So we will take again successive approximation. I have to approximate gxy in a manner that double integration with dx dy setting limit x to x plus 1 y to y plus 1 will result in exactly fxy. And if I take gxy as log a into log a by a minus 1 whole square into a to the power x plus y plus log b into log b by b minus 1 whole square b to the power x plus y plus log a log b by a minus 1 into b minus 1 a to the power x b to the power y plus log a log b by a minus 1 b minus 1 a to the power y b to the power y x. If I take this as gx and if I integrate with dx dy, setting limit to x plus 1 y to y plus 1, it will exactly come as fxy uy into ux, or a to the power x plus 1 plus b to the power x plus 1 x plus y x plus y x plus y plus a to the power x b to the power y plus a to the power y b to the power x. Exactly it will come. We'll try now. A to the power x plus y integration will be a to the power x plus y by log a. Log a, log a gone. Log a is remaining there. Okay. Now we will set limit of a to the power x plus y, where y is going from y to y plus 1. That will come at a to the power x plus y bracket b bracket a minus a minus. We are doing integration with y a minus 1 a to the power x plus y. If this is the integrand, integrating with dy will result in a to the power x plus y by log a. Log a, log a gone. 1 log a will remain. Setting limit y to y plus 1 will become a to the power x plus y in bracket a minus 1. Denominator we have a minus 1 whole square. 1 a minus will go away. Now remaining is log a by a minus 1 a to the power x plus y. We will integrate with dx a to the power x plus y by log a. Again the log a will go away, setting limit x to x plus 1. A to the power x plus y plus 1 minus a to the power x plus y. A to the power x plus y, if I take as common, a minus 1, a minus 1, a minus 1 will go away. Net remaining will be a to the power x plus y. Similarly for b also a to the power x plus y. Similarly for next term also a to the power x b to the power y plus a to the power y b to the power x. Means if I take gxy as log a into log a by a minus 1 whole square a to the power x plus y plus log b by b minus 1 whole square a to the power b to the power x plus y plus log a log b by a minus 1 b minus 1 a to the power x b to the power y plus log a log b by a minus 1 b minus 1 a to the power y b to the power x. Then integrating this with dx dy x to x plus 1 y to y plus 1 will result exactly in fxy. Amazing, mind blowing. This is called This is called transformation of a discrete function into continuous function. So we have learned now that if I have a fx and ux, uy, then I have a gx as surface, gxy as a surface, and its equation is if fx is ux into uy or fx into fy or a to the power x plus b to the power x by square root of 5 into b to the power x b into a to the power y plus b to the power y square root of 5. For this fxy, I have a gxy exactly representing the same thing when gxy is log a into log a by a minus 1 whole square a to the power x plus y plus log b by b minus 1 whole square b to the power x plus y plus log a into log b by a minus 1 b minus 1 a to the power x b to the power y plus log a log b by a minus 1 b minus 1 b to the power x a to the power y. These two are equivalent. If they are equivalent, then for each xy we have a volume with gxy dx dy for each. If I add all the gxy, we get the net summation. What is addition of all the gxy sub-volume? Limit x equal to 1. Now we have taken m and n as odd. We have taken n, m and n as odd. And here we have taken x and y as odd again. Okay. Now if m and n are odd and x is odd, now let's talk about the x-axis and y-axis. Consider this is x-axis, and x-axis we have x equal to 1, 2, 3, 4, 5, 6. We have taken x as odd. That will x as odd. If it goes x as odd, then x will go from x equal to 1, 3, 5, and so on. If y is odd, y will also go from 1, 3, even number it will be missing. In that manner, the area with the fxy, the area with the I'll try again. Now I have x-axis and y-axis. Okay, I have fxy. X is going from, I have taken x and only as odd number. 1, 3, 5, it will go till m because m is odd number. Now for y-axis, it will go as 1, 3, 5 up to n. N is odd number. Now, if I'm trying to calculate sub-volume, then someone would point here how you took x as x to x plus 1. It will go x to x plus 2 because number is odd number 1, 3, 5, 6. And y will go from y to y plus 2, not y to y plus 1. So, we will say yeah. So, we need to modify our expression. If x is odd number and y is odd number, then fxy equal to x to x plus 2, y to y plus 2. That is the change now we have to bring in dxy, dx, dy. Now we have to refine gxy in that manner. If I try to do so, refine the gxy, gxy will be transformed into log a by a square minus 1 into a square minus 1. Earlier it was a minus 1. Now it will be, because if I set limit y to y plus 2, it will become a to the power x plus y plus 2 minus a to the power x plus y. If I take a to the power x plus y as common factor, it will come as it will come as a square minus 1. So gxy equivalent of fxy when it is only odd number is log a into log a by a square minus 1 whole square, a to the power x plus y, log b into log b by b square minus 1 whole square, b to the power x plus y, plus log a into log b, a square minus 1, b square minus 1, a to the power x, b to the power y, plus log a log b by a square minus 1, b square minus 1, a to the power y, b to the power x. This is gxy if x is odd and y is odd. Now to have the full summation, we will take now limit x equal to 1 to m, because m is odd number, perfect. Odd, m is odd and we are taking only odd. Y equal to 1 to n because it is odd number. dxy, dx, dy. dxy we know. If I integrate with dy first, then log a will go away. If I integrate with dx after that, then again one log a will go away. A square minus 1 whole square that need to be settled down. A square minus 1 is A. If A is 1 plus the square root of 5 by 2, then A square minus 1 will come as A only. Someone can try. So A square minus 1 whole square is A square. So someone has to integrate A to the power x plus y with dy. Then it will be A to the power x plus y by log A, log A, log A gone. Limit is 1 to n plus 1 to n plus 2. I'm sorry, it will go n plus 2. Since we are taking double gap, x is 1, 3, 5, gap is 2. Last one will go from n to n plus 2. What I'm trying to say, if this is x-axis and this is y-axis, this last point is m comma n. The last volume will be from m to m plus 2 because we are taking 2 to gap in x-axis 1, 3, 5, m plus 2. N will go from n to n plus 2. So in last integration will be m equal to 1 to m plus 2, n equal to 1 to n plus 2, gxy dx dy. Someone has to find. If I integrate with dy, it will be divided by log a. 1 log a will go away. A square minus 1 whole square is a square. Integration is a to the power x plus y, limit y to y plus 2. If I limit is 1 to n plus 2, it will become a to the power x plus n plus 2 minus a to the power x plus 1 because y is 1. Okay, someone has to fix it, divide by a square. Similarly, you do. And then you try with dx and try to do it again. Whatever comes in term of m and n, a, b, m and n, that is the result. Now someone has to try keeping x as odd and y as even. We have tried x as odd and y as odd. Try x as odd and y is even. If that is the case, then first of all fxy will change. Fxy is uy into ux. Y is even now. Then it will be a to the power y minus b to the power y square root of 5. So gxy will change. If gxy will change, at the end the final limit will be m equal to 1 to n plus 2 because n is odd number. But here it will be m plus 2. Here y will be 2 because we are taking y as even. If it is even, then day number will start from 2, not from 1. 2 to m, 2 to n, where n is odd number. If n is odd number, then last even number will be n minus 1. N minus 1 plus 2, n plus 2. It will go 2 to n plus 2. Okay, if it is confusing, please watch our previous video in single variable. We are doing same thing multivariate. Now we have to keep x as even and then try y as odd and even. And then we have to change m and n. M and n we have taken odd. Keep m as odd only, change n to even. For 16 times we have to do this to get the final result. But this is how it is from the successive integral calculus. We have done for other series also one where we had tried calculating the summation and series for in easier way. Okay, what is the simpler way? Anyone would ask, what is the simpler way? Simpler way to solve this problem is not going for 16 combination. Try solving for single dimension. Keep summation x equal to 1 to n, y equal to 1 to n. This is the dual summation we are taking in two variable case. Keep only one summation, that is x equal to 1 to m and then x equal to 1 to m, means we are keeping only x changing, means un into ux, where x will change, not y, and try to find the solution. Then y equal to 1 to n y into um, where x is fixed. Keep x fixed and try to get the linear summation. Keep y fixed and try to get linear summation. And try to change the integration. I'll try if it is possible here. And then we'll see how we can make it easy. 16 gxy. Right now we calculated 2 gxy. 16 gxy is conversion. Anyway, people can watch, I believe, our previous videos where we have already done. I think 3-4 days back, we had tried more than that, dual variable in Fibonacci series with formula as as u, right now we have taken uy into ux. We have already taken uy into uy plus x. That is that we have done for the dual variable. Someone can watch that. We'll try to cover it if it is possible in simpler manner, but this is the procedure that someone needs to follow, not available in any of the book. If it look tedious, then try to put in pen and paper and see how it can be done in easy manner. +91 is the India country code 948316061 is the telephone number. +91 is the India country code 948316061 is the telephone number.